What's up, math fans? Today I want to talk about amplitude and frequency and how it relates to the sine and even the cosine curve. And in my attempt to mimic that curve, I'm going to wave a string, and it kind of mimics, this is a terrible job, but it kind of mimics the sine and cosine wave. And basically it's literally a wave, whether it's a sound wave or actually, what's interesting, what I found interesting is amplitude. If you look up radio stations, I don't know who listens to radio anymore, but there's something called AM and FM. Look up what AM and FM actually stand for. It's interesting. Amplitude modulation and frequency modulation. So radio signals, radio sound waves are very nicely summed up by, look at that, the sine and the cosine curve as well. A lot of times these functions are used to summarize not only sound, but the air in someone's lungs or the fluctuation in temperature in a certain state. In the summer, the temperature is a lot higher than in the winter, it's a lot colder. So this is really useful, and if you really master this topic, maybe you can move on and discover the latest technology in, I don't know, electrical engineering. So it is really helpful. But I'm just going to explain the basic math behind it. So we've already graphed the sine curve, and hopefully you know what the basic sine curve looks like. Y equals sine of theta. In fact, I discussed it. I'm sure you've seen that video. And I plotted a whole bunch of points, about 24 points. And then I summed it up in only 5 points, the 5 major points. So here's a quick review of those 5 major points. 0 all the way to 360, 180 is in the middle, here's 90 and here's 270, but of course I stopped using degrees, I'm now in radians, so I'm going to call this pi over 2 is the 90, 3 pi over 2 is the 270, and 2 pi. These are my most popular points. Those are not the only points. Obviously, if you continue going on a circle, you continue past 360. So this would continue, and actually in theory you would also look at negative angles, so this would be negative pi over 2 then negative pi, etc., etc., and the wave just continues on forever and ever and keeps repeating. So the basic sine curve goes up to a maximum of 1 and a minimum of -1, and it kind of goes like that, and of course it continues and continues. So where does the maximum occur? Remember, it occurs at pi over 2, the minimum occurs at 3 pi, and here are my zeros at 0, pi, and 2 pi. So that is the basic y equals sine theta. Now I want to talk about amplitude. Amplitude is defined as the highest point of a curve minus the lowest point of a curve divided by 2. So the highest point on the sine curve is 1, the lowest point is -1, and I'm going to use the letter A for amplitude. So that's 1 minus -1 divided by 2. 1 minus -1 is plus. So that's 1 plus 1 is 2. 2 divided by 2 is 1. The amplitude is 1. In short, just look at the highest point. It's going to work out to be the highest point. So the amplitude is 1. Could you look at the equation and know that? Of course. The 1 is hiding right here as the leading coefficient. So the amplitude is the leading coefficient of a sine or cosine function. So if you look at the equation, you can know the amplitude right away just by looking. If you look at the graph, you can know the amplitude by using my formula here, highest minus lowest divided by 2. Or in shortcut, you can just kind of look at the top point and say, oh, the highest point is 1, I guess it's 1. Obviously, this is not drawn to scale because it looks a little higher than 1, but it's 1. You should use graph paper when you're watching this. However, if I take this curve and lift it, doing a vertical shift, and you'll see my vertical shifts in another video, then it's no longer defined as the highest point. Then you got to stick to the formula. It's highest point minus lowest point divided by 2. Because if I lift this thing up, the amplitude stays exactly the same, but the highest point becomes higher. So stick to the formula. Don't just say, oh, highest point, it must be the answer. Not always. Okay, so number 1, what's my amplitude? The amplitude, just said it, it's the leading coefficient, so that means the amplitude is 2. What that means is that it takes your original sine curve, the basic one, the one that I spent the whole video doing, and it stretches it vertically. It doesn't move it, it doesn't shift it, it stretches it. It's like pulling a rubber band. So what happens is every value on that curve doubles. So here at 0, 2 times 0 is still 0, so this point won't move. But every point along the way will move up. And I'll just go to the highest point, the major points. This point is at 1, well, double that, 1 times 2 is now 2. The highest point will now be at 2. And the lowest point, which was at -2, will now be, was at -1, will now be at -2. Let's say -2 is here. And the zeros won't move because 0 times 2 is still 0. So everything along the way stretches and you get a similar curve that's just stretched. So this blue graph is 2 sine theta. And that's it. That's what amplitude does, is it stretches a graph. It's a louder sound if you're talking about sound waves. What about 1/2 cosine theta? What's the amplitude here? It's 1/2. Simple as that. What would that look like? Well, I don't know, I'll underline it in green. So this is the cosine curve, not the sine curve. So you got to remember what the cosine curve looked like. I'll draw that for you. Look like this. Kind of looks like a cup. And I'm cheating, so whatever. Here's my major points. 2 pi. The middle is pi. This 0 is pi over 2. And this one is 3 pi over 2. And the highest point was 1, the lowest point was -1. If you graph the sine curve, this is your common sine curve without any manipulation. So now, 1/2 cosine theta, hopefully I said cosine curve for this. So this is regular y equals cosine theta. But now if I want 1/2 cosine theta, well, that means every value gets multiplied by 1/2 or divided in half, divided by 2. So that y-intercept, which was 1, is now going to be at 1/2. The zeros, again, stay zeros because half of 0 is still 0. So these stay the same, but then -1/2 becomes, -1 becomes -1/2. I'm giving out answers before the question. And again, the highest point will now be 1/2. So it'll be a fatter looking cup, like that. And the same would apply for the sine. It would be a shorter, so I'm squeezing in the graph. All right, so that's what a fractional coefficient would do. Look at number 3. If you can kind of zoom in there, they could give you the graph on a test question and say, well, give us the equation of this thing. So first of all, I want to analyze what the curve looks like, and I usually go to the y-intercept for a clue. If the y-intercept is 0, it's probably the sine curve. If the y-intercept is above 0, it's probably the cosine curve. And with more practice, you'll see that it could be manipulated in other ways. But for now, this is looking like the sine curve. One full rotation of the sine curve occurs from 0 to 360 or 0 to 2 pi. So I see a full rotation and it stops at pi. And then another full rotation before I get to 2 pi. That's 2 full rotations. So it's like you're watching a movie. And the movie's supposed to last from 0 to 360 or 0 to 2 pi. But this movie was so quick, it finished at pi, and then you had time for a whole second movie. So you got to see 2 movies within that 2 pi time frame. So what does that mean? How often did a movie occur? Twice. So the frequency is how many times you see the curve within 2 pi. Here, my curve took a full 2 pi. So that means the frequency was only 1. I only saw 1 curve. Here, same thing. I only saw 1 curve. So how could you tell frequency from an equation? The frequency is also a coefficient, but it's the coefficient of x, or the coefficient of theta in this case. So there was a 1 here, my frequency was 1. There was a 1 here, my frequency was 1. So in summary, the A represents the amplitude, the B represents the frequency. Leading coefficient is amplitude, coefficient of x is frequency. So put that information together, and let's see if we can write an equation of this thing. Well, it's going to be y equals, I know it's a sine curve, so somewhere I have to write the word sine. My frequency is 2 because I see 2 curves from 0 to 2 pi. So I'm going to write 2 theta, 2 curves. And how tall is it it reaches 3 and negative 3, so my amplitude is going to be 3. So there's my equation, 3 sine 2 theta. So when you put all that together, you might see an equation like this or like this. Notice I added a minus h and a plus k. That's for vertical and horizontal shifts, which you've learned with other kinds of graphs. And don't worry, there's a video out explaining that as well. But right now I'm just focusing on the amplitude and the frequency. So this matches this. How about this one? See if you can graph this on your own, all right? Some people like to label their axis first. So this is 0 and this is 2 pi. How can I fit 3 within 0 to 2 pi? Well, there's another formula for that as well. It's actually called the period formula, but I'll explain period in another video. So 2 pi has to fit 3 of them. That means 2 pi over 3 is where the first one ends. So that's going to be 2 pi over 3. Then the next one will be 4 pi over 3. And then finally 6 pi over 3 is where the third one ends. And of course you should know that 6 pi over 3, the middle one was 4 pi over 3. 6 pi over 3 is obviously 2 pi. You just divide 6 divided by 3 to get 2 pi. So here's my 2 pi over 3, here's my 4 pi over 3, and here's my 6 pi over 3. And that's basically it. I fit 3 curves in 0 to 2 pi. But wait, there's more. You want the amplitude to be 2, so I will make this number 2, and I will make this negative 2. And then you just kind of clean it up. So this should actually it's a little cleaner like that, and obviously it'll be even cleaner on graph paper, okay? So this matches that. The frequency means it occurs 3 full curves and it reaches a highest point of 2. All right, thanks for watching. See ya.